Welcome to the Explainer. All right, today we're going to go on a bit of a quest, building a complete web application from the ground up. And we're going to do it with a really powerful, but sometimes kind of overlooked combo of technologies.
Okay, so let's just dive right in with a question you see popping up all the time in developer forums, like this one from Reddit. It really does seem like every tutorial out there pairs Node.js with MongoDB. But what if you like good old SQL? Can you even do that? Is that a thing?
Which, leads us to this question. A stack divided?
So the common perception, especially if you're learning from tutorials, is that the MERN stack is kind of the only way to go. It feels like Node and MongoDB are just joined at the hip. But the reality? Relational databases like MySQL aren't just possible, they're actually a fantastic choice, especially for apps that need really solid data structures. Think e-commerce or financial platforms.
And hey, don't just take my word for it. This isn't just an opinion. If you look at the 2023 Stack Overflow Developer Survey, MySQL is the most loved database out there. Over 41% of professional developers are using it, it's reliable, it has massive support, and it is absolutely ready to power your next Node.js project.
All right, so we've established MySQL is a solid choice, but how does it actually fit into the puzzle? Let's take a look at the three main pillars of any full-stack app.
Okay, let's break it down real simple. On one side, you've got the front end. That's everything the user sees and clicks on, and we're building that with React. On the other side, you've got the back end, the engine under the hood, powered by Node.js and Express.
So let's get a little more specific. Our front end is React, which is just brilliant for building dynamic UIs and managing what we call state, basically the app's short-term memory. The back end runs on Node.js, and we use the Express framework on top of that. Think of Express as the traffic cop, directing all the requests and handling the core logic. And then, of course, you've got our MySQL database, keeping all our data safe and sound in neat, structured tables.
So what connects these two worlds? Well, that's the REST API. You can really think of it as the app's central nervous system. It's not a specific technology, but more like a set of rules that lets the front end and the back end talk to each other clearly using standard web protocols.
Okay, let's jump over to the back end for a bit and see how we actually forge this API backbone.
It all comes down to four basic actions, what we call CRUD operations: create, read, update, and delete. Each one of these maps directly to a standard HTTP method. So, post creates new data, get reads it, put updates it, and delete, well, you get the picture. This is like the bread and butter of almost every web API out there.
So what does that actually look like in code? Well, in our Express app, it's surprisingly straightforward. To read all of our tutorials, we just set up this get route. When a request comes into /API/tutorials, Express knows to run our find all function, which then goes and grabs the data.
And it's pretty much the same deal for creating a new tutorial, right? We just use a post route instead. It listens for incoming data and then calls a create function to save that new info to our MySQL database. Simple as that. Now, to stop all this from turning into a giant tangled mess, we use a standard project structure. Think of it like having a really organized desk. You have a folder for config where your database keys live, a routes folder for all your API paths, a controllers folder for all the logic, and a models folder that defines what your data looks like. It just makes everything so much cleaner and easier to work with as your app grows.
All right, so our API is built. Now for the fun part. Let's actually bring this thing to life on the front end.
So inside our React app, a really common pattern you'll see is creating a dedicated data service. We're using a tool like Axios here to make a clean GET request to our backend's /tutorials endpoint. The whole point is to keep all the data fetching stuff separate so our React components can just focus on what they do best, displaying things on the screen.
And here it is, the whole journey from database to screen, step by step. First, a React component loads up and calls our data service. That service then uses Axios to send a GET request to our Node.js API. The API then talks to the MySQL database, gets the data, and sends it back as JSON. Finally, that JSON arrives back at our React component, which uses setState to update the UI. It's this beautiful, clean loop that just works.
Okay, building it is one thing, but our quest isn't over just yet. We've got to talk about making it secure.
And look, I really can't stress this enough. A working app is one thing,
But a secure app is everything. This isn't an afterthought. You have to be thinking about security from the very beginning. This is so important. Just look at the difference here. On the left, that vulnerable query is just jamming user input directly into the database command. That's how SQL injection happens. It's incredibly dangerous. But look at the secure version on the right. It uses a question mark as a placeholder. It separates the command from the data. You're basically telling the database, hey, this is the command, and this is just some data. Don't execute it. It's such a small change in your code, but it shuts down a massive security hole.
And the good news is, you don't have to fight these battles all by yourself. There are amazing tools that can help. You can use something called an ORM, like SQLize, which often handles this kind of protection automatically. You can use a library like Joy to check all the data coming into your API to make sure it's valid. And you can install Helmet, which with just one line of code adds a whole bunch of security headers to protect you from common attacks.
And that, right there, is pretty much the roadmap. We've seen how React, Node.js, and yes, MySQL can all work together beautifully to create a really robust and reliable full-stack application. So now you know how it's done. You're equipped to make the right choices for your own projects. The only real question left is, what are you going to build?